All right, let's pull back the curtain on the internet. It really does feel like magic sometimes, doesn't it? But behind the scenes, it's not magic at all. There's this incredible, invisible blueprint, a set of brilliant rules that keeps our entire digital world running. So let's dive in and explore them.
I mean, have you ever really stopped to think about it? You click a link and a universe of information just appears. You jump on a video call with someone on the other side of the planet, and it's like they're in the room with you. How does this massive, tangled, global system not just fall apart every single day? Well, the secret sauce is really four core ideas, four brilliant solutions to what would otherwise be four total disasters. And that's what we're going to do in this explainer. We're going to break down each major problem and then the genius solution that keeps the internet humming along. Okay, first up, the problem of things just constantly breaking. It's so easy to forget this, but the internet is a physical thing. It's a massive web of actual cables, routers, and switches. And just like any physical object, its parts can and do fail. All the time. Think about it like your drive home from work. If your usual route is completely blocked by a traffic jam, you don't just park the car and give up, right? Of course not. You find a different way to get home. Well, the internet does exactly the same thing. When one path for your data fails, it just instantly finds another one.
And this amazing ability actually has a name. It's called fault tolerance. It's basically the network's superpower to just keep going, even when some of its pieces break down. It dynamically reroutes your data around the problem, making sure you don't lose service. It's the whole reason a cut cable in one part of the world doesn't bring down the entire internet.
On to the next challenge, and this one is just relentless. The sheer, mind-boggling growth of the internet. We're talking about new devices connecting every single second of every single day. So what actually happens when millions, literally millions, of new phones, laptops, and even smart toasters join the network every day? How does the whole system absorb this constant flood of new users and devices without just grinding to a halt for everybody? The answer? Scalability. This is the network's incredible ability to get bigger and bigger based on demand, all while keeping things running smoothly. And honestly, the internet is the ultimate example of a scalable network. It just keeps expanding and somehow manages to handle the load. Okay, so the network can handle failures and it can handle growth. But what about all the traffic? This brings us to our third big challenge, digital traffic jams. See, not all data is created equal, and if everything were treated the same, it would just be complete chaos.
For example, just think about a video call versus an email. A 1-second delay on your video call can make the whole conversation fall apart, but a 1-second delay on an email, you'd never even notice. That video call absolutely needs an express lane, while the email can afford to wait in a bit of traffic. So how does this work in practice? Well, a router basically acts like a digital traffic cop. When a little packet of video data and a packet of email data show up at the exact same moment, the router knows which one is more important. It identifies the video packet as high priority and sends it first to keep your call smooth, while the email packet waits its turn for just a fraction of a second. And this whole system has a name, quality of service, or QoS for short. It's how the network manages all its traffic by setting priorities. It's what creates those digital fast lanes for data that just can't be delayed, like your video calls or your online games.
So we've got a network that can handle failures, growth, and traffic. But there's one final, absolutely critical problem we have to deal with: bad actors. There are people out there who are actively trying to steal, change, or just block your access to information.
And the solution here, of course, is security, which has three main goals. First, there's confidentiality. That's all about making sure your data is secret, so only you and the recipient can understand it. Second is integrity. This ensures that what you send is exactly what's received, with no modifications along the way. And finally, there's availability, which is all about making sure attackers can't just take down the websites and services you rely on. So there you have it: fault tolerance, scalability, quality of service, and security. These aren't just abstract ideas. They are working together every single moment you're online, creating that seamless experience we all pretty much take for granted.
This chart really ties it all together perfectly. When a router fails, boom, fault tolerance finds a new path. When millions of new users log on, scalability just expands to handle it. When your video call and email compete for bandwidth, quality of service prioritizes the call. And when an attacker tries to steal your data, security keeps it safe. It is an incredible, self-healing, and constantly expanding system. So the next time you're online, you'll know the 4 invisible roles that make it all happen. But it leaves you with a pretty big question, right? As our world gets more and more connected, as we rely on the internet for literally everything, which one of these 4 pillars, failure-proofing, growth, prioritization, or security, do you think will face the greatest test in the years to come?